Okay guys, we're back for 10.2 arithmetic sequences. Again, I know you guys probably have some experience with this, which is why we're doing it now. So hopefully this will go okay. If not, make sure you're asking some questions, okay? Our objectives are seen here. Find the common difference for arithmetic sequences. Write terms of arithmetic sequences. Use the formula for the general term of an arithmetic sequence, and use the formula for the sum of the first n terms of an arithmetic sequence. To begin, our definition of an arithmetic sequence. An arithmetic sequence is a sequence in which each term after the first term differs from the preceding term by a constant amount. So differs by a constant amount. The difference between the consecutive terms is called the common difference. Okay, so let's get going. Okay, so write the first 6 terms of the arithmetic sequence, where a sub 1 is 100. So a sub 1 equals 100. So we have a sub 2, which is going to be, remember this is one of those recursive formulas that tells us it was the one before it, so that's 100 minus 30, which gives you 70. A sub 3, 70 minus 30, which is 40. A sub 4, again that one from before it, so 40 minus 30 equals 10. A sub 5, 10 minus 30 equals negative 20. And then a sub 6, negative 20 minus 30 is negative 50. So our first 6 terms here are going to be 100, 70, 40, 10, negative 20, negative 50. And you see the common difference here is that negative 30. Okay, let's go on. The general term of an arithmetic sequence, the nth term or the general term of an arithmetic sequence with the first term a sub 1 and a common difference d is given by this formula. So this allows us to find a specific term without listing out all of them to get there. So again, all you need is that difference in the first term. So here we go. So find the 9th term of an arithmetic sequence whose first term is 6 and the difference is negative 5. So I have to write that formula back out. A sub n equals a sub 1 plus n minus 1 times our difference. So a sub 9 is what I'm interested in. So a sub 1 is 6 plus, plug in your 9 for that n, 1 times my difference of negative 5. So I end up with 6 plus 8 times negative 5, which we know is negative 40. So a sub 9 is going to be negative 34. Okay, so use the model. So the data in the graph shown that in 2010 that 16% of the U.S. population was Latino. On average, this is projected to increase by 0.35% each year. So it says write a formula for the nth term of an arithmetic sequence that describes the percentage of the U.S. population that will be Latino in years after 2009. So we have a sub n. If it's after 2009, the first year would be 2010. So that would mean that this one would have to be that 16%. So it describes the percentage, so we can do it in percentages. So let me write that out so I don't forget what my formula actually looks like. N minus 1 times my difference. Plus, and then your years, we don't know, it's general, so minus 1. And then that difference is how much is going to increase. Well, it's going to increase by 0.35%. So we can leave it like this, or we can now go through and distribute that. So if I wanted to distribute it, I'd end up with, sorry, my iPad keeps falling, a sub n equals 16, and then it's going to be plus 0.35 n minus 0.35. You're going to combine like terms. In this case, the like terms are your constant terms. So our formula would be a sub n equals 0.35 n plus 15.65. The B part of this question, instead of erasing or instead of redoing the whole page and creating a new slide, I'm just going to erase here, and that way we can find it. So it says, what is the projected Latino population in 2030? So if you know this began in 2009, what's the difference between 2009 and 2030? Well, that is going to be 21 years. So we can do A sub 21 equals 0.35 times 21 plus 15.65. When you put all this together, ends up being approximately 23% will be Latino. Okay, so now we're on some try it yourselves. So our first try it yourself says that you want to find the eighth term, so n equals 8. First term, a sub 1 equals 4, and the difference equals -7. So we're going to be able to find a sub n equals a sub 1 plus n minus 1 times d gives me a sub 8, 4 plus n minus 1, so 7 times d of -7. So that gives me -49 plus 4 is -45. Okay, so the second try it yourself here tells you, according to the National Education Association, teachers in the United States earned an average of $30,532 in 1990. This is increased by $1,072 per year. So this is the average. So it says write the nth term arithmetic sequence and describing average teacher salaries in years after 1989. So we have a sub n equals a sub 1 plus n minus 1, and then times our difference, d. So we know if our first year is going to be a sub 1, that's 30,532 plus n minus 1, and my difference here is an increase of $1,472. Again, if we wanted to write that out as an actual nice looking formula, we're going to distribute that in. So I end up with 30532 plus 1,472n minus 1,472, which gives me a sub n equaling $29,060 plus 1,472 times n. So how much will the average teacher make in 2010? So 2010 is going to be 2010 minus 1989 it's 21. So a sub 21 equals my 2000 plus 1. I've got to get rid of that. 1472 times 21. So let's do that real quick. 21 times 1,472. That's 30,000 plus 29,060. So it says the average would be 59,972. I'll tell you that's probably not super accurate, I would assume, unless you're maybe in a big city. Okay. So the sum of the first n terms in the arithmetic sequence, so the sum s sub n of the first n terms of the arithmetic sequence is given by s sub n equals n divided by 2, first term plus your last term. So this says find the sum of the first 15th terms. So again, you could do this the old-fashioned way where we actually figure out the difference between them and then figure it out. But we can use the tools we have. So the first part would be finding our 12th term. So you're going to use that a sub n equals a sub 1 plus n minus 1 times d. So that's going to be 3 plus a sub 15 minus 1. My difference here, so it's going to be a positive 3 because it's going up by 3 each time. So it gives me 3 plus 14 times 3. Which gives me 45. So my first term, or my 15th term, is that. Then we can use the formula we just got. S sub n equals n divided by 2. A sub 1 plus a sub n. So our sum of our first 15 is going to be 15 divided by 2, which we know is 7.5. My first number is 3, plus my last number is 45, which gives me 48. When we put all this together, you end up with the sum of your first 15 terms being 360. Okay, let's try this again on our next try it yourself. So the try it yourself here says find the first 100 terms. 1, 3, 5, 7. We see that our difference between each of these is going to be a plus 2. So we have a sub n. Remember we use that formula of a sub 1 plus n minus 1 times d. So a sub 100 is going to be 1 plus 100 minus 1 times my difference of 2. So that gives me 99 times 2. Plus 1, which is 199. Okay, and then we do a sub 100. Nope, I'm finding the sum, so S sum of the first 100 is 100 divided by 2 times my 199 plus 1. That gives me 100 divided by 2. I know that value. 50 times 200, which is 10,000. Okay, guys, let me know if you have any questions.